Last week, we solved systems of equations by graphing. So systems of equations are where you have more than one equation, more than one variable. So we graphed two lines, we solved for an x and a y coordinate, and we did that by graphing. The problem is, most of you probably don't have just a sheet of graph paper sitting in your back pocket that you can draw graphs on and find systems of equations to. So what we're going to do now is a more algebraic approach called substitution, and this way will work pretty much every single time, and you don't have to have a graph handy. So we're going to start with substitution. And first we're going to look at some money. So we know that $1 could be broken down into change, and you could have 50 cents worth of quarters, and you could have 10 nickels, that's another 50 cents. And if you add those together, you still have $1. So it's an equivalent amount. It's a much more annoying amount to try and carry in your pocket or your purse, but hey, it's still $1. It still spends the same. Similarly, we know that this $1 bill on the bottom is equivalent to this stack of change. We've got 80 cents worth of dimes, that's 8 dimes, and we've got 2 stacks of 10 pennies, which makes 20 cents worth of pennies. And again, really annoying, but if you add them together, it ends up equaling $1. So hopefully you agree that this stack of change and this stack of change, they're the exact same. So you could replace, think mathematically here, you could replace this dollar with this stack of change. So put that stack of change right over there, and you'd end up with this. You've got this stack of change, 2 quarters and 10 nickels. And this stack of change, what do you know about them? Well, they're both equal to each other. They're both equal to $1. So even though they look a little bit different, their values are still the exact same. And we're going to treat systems of equations the exact same way. Pretend for a second, I'll use a different color. Pretend that this dollar bill is like a Y. And all of this gobbledygook over here, that's going to be your math equation. And similarly, this y is equal to this mess of gobbledygook. What we realize is each of these sets of gobbledygook are the same as each other, and we can set them equal. Let's go ahead and do an example so you understand what I'm talking about. First example says solve the following system of equations and then show that your answer is the same. Let's relate this back to money. This y is like your dollar bill, and it's equal to this mess of change, that gobbledygook. And this dollar bill is equal to this mess of change, that gobbledygook. What we realized just previously was this amount of change and this amount of change, they were the exact same, so we can set them equal to each other. And we end up with 4x plus 80 is equal to 7x plus 20. So I'm going to slow down just a little bit. We knew that y was equal to 4x plus 80. So all I did was I substituted this y with 4x plus 80. And you end up with 4x plus 80 is equal to 7x plus 20. Now we've got this equation, and we can just go ahead and solve it. So we've got variables on both sides, 4x on the left, 7x on the right. You can solve it however you'd like. I would move the smaller x first. So in this case, I would subtract 4x from both sides. And then the 4x disappears. We're left with 80 equals 3x plus 20. And if we're trying to get x by itself, that 20, that has to go. So we're going to subtract 20. We're doing the opposite to both sides. And then the 20 goes away. 80 take away 20 gives us 60 is equal to 3x. And if we divide both sides by 3, we end up with x is equal to 20. And you might get to this point in the problem and you might feel pretty good about yourself and then move on to the next one. You can't do that yet. Remember, this is a system of equations where you have more than one equation and more than one variable. We solve for x but we haven't solved for y yet. So let's go ahead and do that. I'm going to use the top equation to help me solve for y. So we have y equals, I'll just rewrite it, 4x plus 80. And you can pick either the top one up here or the bottom one here. It doesn't matter which one you pick. You're going to get the same answer. And for the purposes of this, I'm going to check them both just to make sure that my answer is good. What we just found here was that x is equal to 20. So I'm going to replace this x with a 20. So we do y equals 4 times 20 plus 80. So we substitute x with a 20. Then it's just a matter of simplifying. 4 times 20 becomes 80. And if we add these together, we get 80 plus 80 is 160. And that's my value for y. So we've solved for x and we've solved for y. When you are all done, make sure that you write your answer as a coordinate, because remember, what you're actually finding is like a spot on a graph where they cross. And so our coordinate would be 20 for the x coordinate, 160 for the y coordinate. And that's going to be your answer. Now let's just double check and make sure that our answer is correct. We checked it with the top one already, but let's go ahead and check it with the bottom one, just to be sure. So we have y equals 7x plus 20. So here I'm just writing down this bottom equation. And let's substitute our value for x. So we knew that x was equal to 20. Then we can simplify. 7 times 20 gives us 140. And if we did it correctly, the value that we get here should match up with what we got here. And it does. Both of them equal 160. So we know that we've got the correct answer, and we can rest assured that, hey, we didn't make any mistakes. So our final answer is 160. But if you want to be a good student, check it with both the top and the bottom equation. Let's go ahead and do one more example. We have y equals negative 5x plus 16 and y equals negative 3x plus 24. What I can do is I can take this value here and I can substitute it for this y. So we're going to have negative 5x plus 16 equals negative 3x plus 24. To solve this, again, you can do it however you were taught, but I would move the smaller variable first. So I'm going to add 5x to both sides. And by doing that, the 5x's go away. We're left with 16 equals a positive 2x plus 24. Negative 3x plus 5x is a positive 2x. To get x by itself, that 24 has to go. So to get rid of a plus 24, we do the opposite. We're going to subtract 24. And it goes away. If you take 16, take away 24, you're left with a negative 8 equals 2x. And finally, that x is being multiplied by 2. So to get rid of it, do the opposite. And we're going to divide by 2. And we're left with 1x is equal to a negative 4. So we've done all that work, and we've found that x is equal to negative 4. Now we have to solve for y. And you can pick the top one or the bottom one. It doesn't really matter. Let's just pick the top one for now. We have y equals, I'll rewrite it once again, negative 5x plus 16. And what we just found out was that x is equal to negative 4. So I'm going to replace this x with a negative 4. Then it's just a matter of simplifying. If we take negative 5 times negative 4, a negative times a negative makes it positive. And if we add those together, 20 plus 16 becomes a 36. 6. And that's our value for y. Once again, if you're going to be a good student, you might as well be, go ahead and double check it for the bottom one. So I'm going to rewrite the bottom one, negative 3x plus 24. And we can again replace that x with a negative 4. And we can hope and pray that it equals 36. If you take negative 3 times negative 4, it's a positive 12. And 12 plus 24, it gives us 36. So whichever one we pick, the top one or the bottom one, it still gives us the exact same answer. So for our final answer, remember to write your answer as a coordinate. Our x coordinate was negative 4, and our y coordinate was 36, and there is your final answer. You have 2 of them to do on your own for your assignment. You'll probably need the password, so your password for this week or for this assignment is going to be Knights. K-N-I-G-H-T-S. This will be a lowercase k. So you're at Harding, you're the Harding Knights. So there's your password. Go Knights. Go ahead and try the next 2 on your own. Good luck with those. And remember, you can always double check and make sure your answer is correct by plugging them into both the top and the bottom. And then you can rest assured and know that you got them right. And that's it for the first part of substitution. Come on back for the next video where you learn about the next part of substitution.